The energy crisis, it's a global problem. Of course, it affects every country that does not produce oil on its own. The way to solve this problem is to reduce global dependence on fossil fuels. The energy program that the Technion has set forth is a very broad, comprehensive program, and it aims at coordinating the energy research on campus between 9 different faculties and dozens of researchers. We focus on specific areas which we feel would be highly beneficial both on the Israeli scene as well as across the world. This includes solar cells, wind energy, and it includes another very interesting subject, which is called solar thermal. In other words, how can we utilize the thermal or the heat energy from the sun?
Air conditioning is a very good application for solar energy because when you have the most solar radiation is when you need most air conditioning. Unlike solar space heating, which is the other way around, when you need space heating, most often you don't have enough sun. Air conditioning has 2 basic functions. One is to lower humidity, the other is to lower temperature. Sometimes lowering humidity requires more energy and is more important than lowering the temperature, especially in humid climates like Florida. Most conventional air conditioning systems do not give you independent control of humidity and temperature. You have one thermostat and either you lower the temperature and then the humidity may not be right, or if you lower the temperature further, the humidity is going to be right, but then you may be too cold and will have to wear a sweater. Our system enables us to use solar energy for dehumidification.
If we're able to generate electricity out of the sun, we must also develop the way to store that electricity. It means batteries. So we have terrific scientists working in this area.
The energy devices that here we are exploring and studying are fuel cells on one hand and batteries on the other hand. You have to understand that technology is moving very fast. For example, electric vehicles is very important because you would like to guarantee the customer freedom. Do not worry about charging. What kind of system can give you that? Batteries is capable of doing that if you design the material properly, and that's what we are doing here. We are introducing much more energy and extended cycle life.
We have a biofuel effort focusing on the genetic engineering of plants. So this particular effort is led by a biologist and by a biotechnologist and chemical engineers.
The Technion, of course, is an ideal site for this type of research because it has inside expertise. Professor Gebstein in the biology department is trying to design or engineer plants with good properties in terms of bioenergy crops. Once we get the crops from his side, our part will be to design enzymes or proteins that in a biological manner will break down these plants into soluble sugars that can be used for energy source.
Another area is the development of nitrogen, hydrogen alternative fuels. And the challenge there is to be able to utilize them in an efficient and clean way. Areas that I will personally be engaged with. Energy conservation includes making efficient buildings that involves architecture, urban planning, and civil engineering, where the idea is to put together a model home that uses the best technologies that we know today. The Technion is a special university. The amount of cooperation that we have with the industry is outstanding. In the field of energy, one of the examples is a fuel cell company that is recently set up by a Technion graduate, developing more efficient energy conversion systems. The vision of the research of the Technion Energy program is all high-impact projects, and I firmly believe that any of these projects, if successful or when successful, can have a high impact on both the Israeli as well as the global energy crisis. This is our vision. We are aiming high, and with the right support that we are going to generate for this program, we will make it.